Software Architecture with Steve Smith.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. I'm excited about a returning guest from episode 276, Stephen Smith. He's also known in the developer community as Ardalis and on social media everywhere. He's an entrepreneur and author and software architect with a deep passion for building effective and maintainable software. And through his company, NimblePros, he helps organizations ranging from household names like Microsoft and Quicken Loans to growing teams across industries. He helps them maximize their development potential. And his clients frequently describe him as a force multiplier, amplifying the productivity and impact of the teams he supports. Steve has also been recognized as a Microsoft MVP for over 2 decades and continues to lead through education and mentorship. He's published so many courses on Pluralsight and Dometrain. He focuses on topics like domain-driven design, software architecture, design patterns, and others. And he also really enjoys empowering developers through his mentorship platform, devbetter.com, where he helps the next generation of professionals grow their careers with intention and clarity. Steve, welcome back to the podcast. How are you, sir?
I'm doing great. How are you doing?
I'm good. Good to see you. Great to have you back. You've been on several times now. So that's awesome.
Is 3 or 4, yeah.
And we'll include a link to the past episode in the show notes. But for those listeners who maybe they haven't seen you speak at a conference or other public speaking appearances, if we go back in time, are there any turning points or highlights that you want to highlight in your career of kind of what keeps you just super excited about computer programming and software architecture?
I think it's just about solving problems. I've got, I'm a typical engineer, or I see problems and I just want to figure out how to solve them. Like they're puzzles, and if things aren't working the way they should, they're given the wrong results, or they're not running as fast as they should, or whatever it might be. Like those are just fun things to see improved. And some of the things that make that better is faster feedback loops. Like if you're on a project that's like waterfall and it's just a grind for months at a time before you know anything about whether you're even building the right thing, that is not very motivational, at least not to me. But once web programming came around, which I was around when it did because I'm old, and you could just hit F5 refresh in the browser and see the thing that you just changed, like at least for yourself.
Yeah.
That was a huge win as far as feedback. And then agile methodologies and continuous integration, continuous deployment, those are all things that I love and I promote. And I love seeing teams get lit up by the excitement of, hey, we just put in this change for this fix or whatever, and now it's out there like less than an hour later, and we're already getting thanks from the customer. Like that's great. That's amazing.
Yeah, for sure. Well, you do quite a bit of public speaking and presenting just on general architecture topics. And I would lump in domain-driven design with some type of architecture thinking. And we have a variety of listeners here. In your words, how do you delineate between just design, coding choices, and what the heck is software architecture?
Sure. So software architecture is sometimes hard to give a good definition to. A classic definition that's been used for a long time is software architecture is comprised of the decisions you make that are expensive to change later, right? So much of what we do in software development, we can name a class one thing and then a couple weeks later realize that wasn't the best name, and we can just use a renaming, refactoring in our IDE and check that in and move along, right? There's no big deal usually. Now, if you code really poorly, it might be more expensive to fix that kind of problem, but generally it's pretty cheap to fix those types of things. But if you have built your entire platform on a particular architecture, let's say, or even a particular framework, right? Those are decisions that, 6 months down the line, if you change your mind, it's not that quick to go from React right over to Angular, at the drop of a hat, or switch from .NET Framework to something else, or one particular architecture for another. And so, things like whether or not you're going to go full microservices or you're going to use a monolith would also fall into that same category, where it's not necessarily going to be trivial to switch back and forth between those choices later on down the line if you decide that you made the wrong decision or the needs have changed.
Mm-hmm. Yeah. Yeah, I've seen various debates on. I heard it quipped, architecture is the hard stuff, and but it seems like it's somewhat of the eye of the beholder. But what I think about is if you were to draw the shape of the system, what would you draw?
Right.
And it helps me sometimes.
And like the different pieces of it and how they interoperate, it's like boxes and lines at the end of the day is what architects like to draw on the whiteboard or whatever. But it's, the different logical pieces of the system and where they live relative to one another and how they pass messages back and forth to each other or how they communicate with one another. And it's just a question of like, well, how do you delineate those things? How do you split them up? And how do you group them together? And then, how do you deploy them? And all of those questions are, architecture, right? They doesn't matter what the code is. It doesn't necessarily matter what the operating system is that they're running on, or even the product that you're using. It's just the logical components of a software system and how they're deployed and how they talk to each other.
Yeah. Well, in the building space, we're kind of used to somebody has the job of the architect and they produce some things, and then the builder kind of builds something according to the architecture. But then there's this thing called the blueprints, and it has a number of pages, and the floor plan and the foundation and the electrical and all that. And so in your mind, and you can do all kinds of stuff, but what have you found is helpful when you think about what necessary artifacts you like to get everybody on the same page for architecture decisions?
I'm not a huge fan of like a lot of the classic UML diagrams, but I do like some of them. So, sequence diagrams I find are very illustrative of how communication flow is going to happen for a particular use case or scenario in the system, where you can show like the user does X and that flows into this entry point in the system, and then that further communicates here to here to here. And those different points that it's communicating with might live in the same process. They might live across different process boundaries. So that some of the different UML diagrams I think are very useful. C4 diagrams can also be good for breaking down things from a high level down to a lower level. I found those to be helpful. One of the things I use quite a bit lately is event storming, which is often used in domain-driven design as a way to kind of get a good picture of what the domain, what the business model of the system is, and how the different pieces interact in real time, like as things are happening in the business. And so you can take those event storming artifacts, the diagrams and things that you produce there, and refine them and build them out to the point where they are, representative of different elements within your system, even different aggregates and entities at the lower level, to help you kind of visualize how things happen. And the thing about those event storming diagrams and the UML sequence diagram, they both have the benefit of showing something live, of showing some actual runtime action taking place that you can see over a timeline, as opposed to a more static diagram that looks more like a networking diagram that just shows you like, here's all the different pieces and some arrows to say they talk to each other. It doesn't show you like necessarily the order in which they talk to each other or what initiates the communication in every case, right? So they have their place, but they aren't always as good at showing how things work as the more sequence and event-driven diagrams.
You mentioned C4. Just for anyone who has never heard it, it's the C4 model. Simon Brown is the guy who kind of popularized that, and we'll include a link to it in the show notes, c4model.com. And actually, we'll include a link to episode 96 of this podcast where he was a guest on the show. So that might be interesting. Go deep. Because, yes, I like C4 as well.
I was a combat engineer, so I was really an expert with C4 for a long time before I'd ever used it in software. And
Nice.
there's a quote that we always had, which is, "There's no problem so big that a suitable amount of plastic explosive can't solve it." But the C4 diagrams that he has are context, containers, components, and code, and they're just a way to start really big picture and then just gradually narrow it down as you're designing or thinking about a system.
Yeah. And you've written an ebook in the past. I'll include a link to it. It's been a number of years now, Architecting Modern Web Applications. And you link to it from ardalis.com. But I remember older, now they're maybe 20 years old now, books on, patterns of enterprise application architecture and design patterns and all these. But are there any more modern, let's say even the last 10 years, books on architecture that have caught your eye or you think are useful, or is it just not that way anymore? The phase of architecture books.
No, I think they're still being published, and O'Reilly has a bunch of good ones. Mark Richards and Neil Ford are really prolific authors on this topic. One of their books they published a few years ago that I really like is called Fundamentals of Software Architecture. It describes the two laws of software architecture, which I really like. And then it covers, I don't know, like 10 different discrete architectural styles, and has like a breakdown of, it's all about trade-offs. And it's the first law of software architecture is everything's a trade-off. Mm-hmm. And they kind of break down like, what are the trade-offs between these? Like, what are you optimizing for if you choose this one, and what's going to be harder because you chose this particular architectural style? So that's a book that I've recommended quite a bit in the last few years, and I really enjoyed and learned a lot from.
Nice. Okay, we'll include a link to that in the show notes. And you do this as well as a consultant. You encounter all kinds of engineering teams with different levels of experience. And like you mentioned, I think you have a few years on me, but we both got started in the 90s at some point, and so like pre-internet,
Right.
Then, but with the growth, you've got massive numbers of developers who, it's like HTML was one of the first things that they learned, and now we're on this new paradigm where AI-driven development, it's like the first skill is not just HTML. And so it's like, how do you learn architecture from just coding, and how do you sort out, it's like, okay, no, this is a design pattern, or this decision fits within the architecture versus this decision, this is an architectural decision. This is going to impact so many different things. Do you have any kind of process for that, or is it just you kind of figured it out through experience?
I think a lot of it is experience, but one of the biggest things I think that you need to understand when you're deciding how to architect a system, the first rule you should probably follow is keep it simple, stupid. Just follow the KISS principle, and not make it more complicated than it needs to be for 99% of the apps that you're building, especially if you're a new developer, you've got a year or two of experience at the most, or you're a student and you're just trying to kind of figure out how to write code that works. Like, you don't need to build some microservice-based architecture with a bunch of moving parts. You just need to write something that's simple and works. Once you've got it simple and works, then other things that you can apply, one that I often preach is pain-driven development, which is, if it's causing you pain, then respond to that by refactoring in some manner or changing in some manner, right? If it doesn't hurt at all, you don't need to change anything. And so build the simplest thing that works. And as you extend it and you work with that, it'll start to cause you pain in some manner, or users pain, right? Like, the application is too slow because it can't scale, because you're one of those, 1 in 1,000 developers that built something that a whole lot of people actually want to use. And so you actually need to scale it up. Spoiler alert, most apps are never going to have more than a handful of users, and that's never going to be a problem. But it is worth knowing how to scale things up in case you need it. And also because with a lot of these cloud-hosted platforms, you're paying per unit of resource utilization. So if you build really inefficient solutions, it's also going to be more expensive to host, even if it only has a few users. So any of those areas where it causes you pain, it's too slow, it's too expensive, it's difficult. When I want to add a new feature, I have to copy paste all these things, and then the user changes their mind about something. Now I have to go fix it in 5 different places. That's painful. Like, those are all things that should drive you toward a better solution. Yeah.
In my own experience, like, you keep it simple, and it reminds me of the old Yagni saying from the Agile community, you ain't going to need it.
Yep.
Or, wait until you do need it. I find myself, again, maybe it's just some habit, but when putting together a new application, I might need a bunch of things, but you know what? I'm going to need some central library and quick decision. I'm probably going to be using SQL Server. I'm using .NET. So, okay, I need some sort of database. And so it's like, there's these core set of patterns or structure that I'm pretty darn sure are going to be at the middle of this application, regardless of all of the other things that it ends up needing. And it was really interesting because just a few weeks apart, you were interviewed on the .NET Rocks podcast, a few weeks apart from Jeremy Miller, and you were talking about architecture versus code. Jeremy Miller was talking about vertical slice architecture. And it's almost like I could put those two episodes together and, Jeremy's like, I don't like any kind of layered architecture. I like vertical slices and put all the dependencies together. And you were, kind of advocating for some type of dependency management. And it's like very different opinions. Kind of maybe defend your opinions is what's led you to just that kind of general approach when starting a new application.
I think all of us are colored by our context and our history and the things that we've learned through painful experience. And I think Jeremy has his own background and he produces a lot of great stuff that I love and we're friends and we talk at conferences and stuff. And I have a different background because I'm in the consulting business and I'm talking to a lot of clients who have coded themselves into a corner, have, built something that didn't have any of the structure that perhaps it needed. And oftentimes was being built by, novice developers who didn't have the experience to build something better, or when they did have the experience, management didn't give them the opportunity to refactor it into something better, which is super common. And so they're living with this thing that is just totally overwrought with technical debt. And even minor changes are taking weeks or months because they're having to code around all these, problems in the code, right? They're usually just what we would traditionally call big ball of mud architecture, where there isn't a really cohesive set of rules being followed. Sometimes I've seen both extremes, or sometimes they have this project that has 10 developer years worth of effort in it and, hundreds of thousands of lines of code, and it's a single project and it's, VB.NET web forms running everything. And now their business is taking off and their competitors are coming after them and they're trying to be agile and pivot and, add a new, line of business or something. And they can't get anything done because this whole morass of code is holding them back. Right. And they don't have any tests, right? Because it's really hard to test that kind of thing. And everything is tightly coupled, which makes it even harder to test. Or on the other end, I've seen teams where they have 150 projects in Visual Studio and the build time is tremendous and it takes forever to figure anything out or see where something is. And, you've got projects that have like one interface in them and that's it. And it's there because somebody wanted architectural purity. And, it's like the other extreme of where we'll have, a gazillion projects where we maybe didn't need quite that many. And at the same time, it's like slowing things down. And a lot of times they don't have enough tests. And, these are things that I see and I've got kind of a set of patterns that I've used and I didn't invent them. Like I've tried a bunch of things and these are things that have worked for me. And so we experiment, and I don't have a cookie cutter approach for every company or every team, but generally being able to take your dependencies and put them at arm's length and be able to swap them out is something that offers a lot of flexibility. Not just being able to test, but I hope we have time to talk about some other design patterns and architectural things that that you get if you have some type of abstraction between you and out-of-process third-party dependencies that you rely on.
Well, let's talk about that because you've mentioned a lot of times, or you have a whole course on clean architecture, right? From Pluralsight?
I don't. Other folks do.
But you've done a lot of speaking on that.
I have done a lot of talks on it.
Kind of, yeah. That's your approach. So maybe just for the listeners who haven't heard that, give an overview on just kind of the principles that you think of when making those decisions.
Sure. I think clean architecture goes very well with domain-driven design, which I talk about a lot as well. And the idea in both of those courses, both of those topics, is that the primary focus is on the business logic, right? Like that's the main thing that the whole value that you're bringing is you're automating some business process, and you want to ensure that it's correct. And you want to ensure that as the definition of correct changes over time, which it will, because you're going to learn how it works better and the business is going to change how they do things, that the software remains soft, that it remains malleable and changeable. And so the best way that any of us have found to ensure that that's the case is to keep that code not tightly coupled to its infrastructure concerns and heavily unit tested so that you know that it does what you think it does. And if you change it in any way, you know it still does what it did yesterday or 2 commits ago. And so by focusing on that, by saying we're going to have all the business logic in one place, if you're doing domain-driven design, that's going to be the domain model. That's going to live in the center of clean architecture, which is very similar to hexagonal architecture or ports and adapters, or Jeffrey, your onion architecture that you wrote about 15-ish years ago.
15
all
plus,
of those
yeah.
things are basically the same, with the idea that domain logic lives in the center and all dependencies point inward. So that means your infrastructure concerns, which are out of process things like talking to a database or sending an email or reading a file, those things live in a separate project and depend on that domain logic in the center, which is following the dependency inversion principle from the solid principles. Because traditionally, typically, your software would say, hey, I need to get something from a database. Okay, new up a connection, call the database, wait for the result back. Okay, keep on running. And now whatever method that's in, if you want to test it, guess what? You've got to have a database that you can open a connection to and wait for the data to come back. And so now your tests are brittle and slow. And so by having this abstraction in place, having dependency inversion, it makes it so you can test that business logic without actually having to talk to the database. And that is the key to making all this stuff work faster. So the typically 3 minimal projects you'd have in clean architecture would be your core, your domain model. Then you'd have your infrastructure, which is everything else, like I mentioned. And then whatever your entry point is, usually a web application or an API or maybe a console app or what have you. A fourth one that you may have is called use cases. Use cases correspond to separate user actions typically. So this might be something like create a task or mark a task as complete or whatever your domain is. And those would then use the domain model to perform those actions.
You mean like commands?
They'd be commands and queries. That's right. Commands and queries. So at a minimum, they might be CRUD things like get this thing by ID, list all those things, create one of them, update one of them, delete one of them. But sometimes they're more domain specific. So it might be something like approve this loan, right? And all the work that has to do with that.
Yeah. Well, you mentioned calling things that are out of process. And there's so many examples from the database is there, but you could run the database locally. But I'm also thinking about something that's very common these days with online applications, which is sending text messages, integrating with users. Well, none of us are going to have a text message server of some sort. That's like Twilio has a whole business because turns out that's a hard problem to support all of the different carriers and the differences. And so we, happily use an online service. It's something we are not going to control that. And they're not going to give us a test environment. Maybe they'll give us a test account and all that we can do. But like you said, for testing, I don't want to actually round trip through Twilio just to run all of the tests in my build. I want to, short circuit it somehow. So with that particular example, what's your preference and how have you found it the best to handle kind of service provider integration like that?
For anything like that, I use an interface in C# as an abstraction. So, I might have an iEmail sender for sending emails. I might have an iSMS sender for sending text messages. I wouldn't use the same thing for both because they have different message properties and structure and whatnot, right? But your application probably is aware of which type of thing it's trying to send to, and will use the appropriate interface when it needs to. And so in production, I'm going to wire that thing up to my iTwilio message sender. But everywhere else, it might be a fake one or a console log one or something like that, where it logs something to the console and says, "Hey, I just sent this message." Wink, wink. Right? It didn't really, but you can look at it and see as a developer, it did what it was supposed to do. Or if you're writing tests, you can just mock it and verify that it was called and move on with your business as far as that method is concerned.
Yeah. We referenced kind of being middle-aged a couple times. And, with that, I remember when there's lots of conversations about the Gang of Four design patterns book, which is quite old now. And one of those patterns, I keep on coming back all the time, is the adapter pattern. And then just like my progression, then later on, Martin Fowler kind of published an article about a gateway pattern, which is kind of a type of adapter, but specifically for a external API, external service of some sort. And that's what it reminds me of, that these kind of patterns, this language, are many, many, many years old. And even though we may, use new tech and cloud this and container that and AI this, a lot of these design concepts have been around for a long time. And for younger software engineers, it's just about, I guess, having an inventory of those in the tool belt to be able to say, this one's appropriate. Okay, I'll follow that pattern. And then the other people on the team, now there's a language. Okay, talk to Twilio. We're going to use the gateway pattern. What is it in .NET? Well, it's a C# interface, and we're going to have an implementation in a different project. And that's what comes to mind. How do you think of it?
Yeah, same. Yeah, usually I just think of them all as adapters for the most part. But yeah, once you've got an abstraction that describes what it is you're trying to do, that's the thing that I've been trying to teach folks. The terminology I've been using most recently is that your interface, your abstraction says what you want to do. Your implementation says how, right? And there shouldn't be any indication of how inside of the abstraction. And then the adapter implementation, it worries about that. So, you might have an interface that wants to save some data, let's say, to a file, right? Well, maybe you want to save that locally to a file. Maybe you want to save it to Azure Blob Storage. Maybe you want to save it to Amazon S3. Well, what you want to do is save a file. And so that's what the interface will be concerned with. And it might know things like, what's the name of the file? And, here's a byte array of the data that I want to put in it, or a string that it'll just, save it as a text file, whatever. And that's it, right? And then how it does it will be the responsibility of the implementation. And by doing that, some will argue that is, adding extra complexity, right? Because, oh gosh, Steve, now you've got two files, right? You've got this interface and it's so huge. It's got 3 lines in it, and that's going to confuse people. And then your actual implementation is just exactly as long as it would have been, except at the end of the class line, it has a colon and an I file, service line. Like, it's so much more code. And they get put off by that. But the effective options that gives you later are so massive that I think any argument about the complexity, if you do it right, is really hard to give with a straight face, because it's so trivial to just add that interface when you first need that out of process thing, and then it opens the door to all manner of implementation options and the ability to use decorators, which is that other pattern that I really want to talk about if we have time, to extend the behavior of any of those things that you're doing, even if you're only ever going to talk to one external system, or you're only ever going to save to your local file. The ability for you to add decorators on top of that makes a huge difference in your architecture and your design, as far as how you can structure that and how little code you'll have to write to implement a lot of cross-cutting concerns.
Yeah, and you mentioned interfaces. I just did a quick search and found an estimate of 5,000 interfaces across just the .NET base class libraries. So, but you mentioned talking about decorators. If we have time, let's do that now.
Now is the time. Yeah. Okay. All right. So if you don't know the pattern, the decorator pattern, it's a pretty simple one, right? So, and actually we mentioned the adapter pattern. So let's talk about that one real quick. So an adapter is just a standard interface that you provide, that you define, that you own, right? It should be part of your code. And you say, this is how I want to talk to things that do a certain thing, that save a file, right? And then you might have different ways you want to implement that. Like I mentioned, local file, Azure file, whatever, right? And so those are each implementations that will adapt to your interface how to do that, right? Azure's already got an SDK that you can call that says how to write stuff to blob storage, and .NET already has file IO that you can use to write the local files. You're going to hide those direct implementation details from your application, and instead your application is only going to know about your adapter, your interface. And then you'll have an adapter, which that concrete class that kind of translates from your high level domain intent of I want to save a file down to a low level how to save that. I'm gonna use a string writer, and I'm gonna write it to this file in this folder, and I have to name it a certain way, and it has to have an extension. Like all those details, your application doesn't care about, right? But your adapter needs to know about the details because it knows about how, not necessarily what. All right. So now you've got this adapter. That's great. You can go and write to the file system, and you could have done that anyway, right? You could have just written it all in line with some Microsoft file IO code, and it would have been fine. But then some more requirements come along, like, hey, you know what? What if that file's not there and it blows up? I want to make sure that we always log the exception a certain way. Or what if it is successful? I want to log that too. Or maybe it's expensive for me to read this file. Why would it be expensive to read a file from your local machine? Well, sometimes it won't be local. Sometimes it'll be on a network share. Sometimes it'll be in the cloud. And we get charged per thing. So we want to be able to cache that. Okay, well, we'll add some caching logic. So if you do it all in line, and you want to make it so that you could talk to the cloud, you could talk to the local file, you have consistent exceptions and try-catch blocks. You also want to make sure you can cache it and you log everything consistently. Now that little bit of code that was like, save this file inside of your bigger method that's doing other things, right? Now it's 200 lines long with a bunch of if statements and try-catch blocks and all this other logic to do all those other cross-cutting concerns. If you use the decorator pattern, you would create your adapter that talks to whichever thing. You would inject in whichever type of thing you wanted to use, local file, cloud, whatever. And then on top of that, you would decorate it with a wrapper class that adds additional functionality. Right, you could wrap it with a class that does error handling, and it will be the same class that you wrap all those different implementations with, right? So the file IO, the Azure cloud, the AWS cloud, none of those will have any error handling in them. You'll just put that in the decorator, right? And now you didn't have all that duplicate code. You need to do some logging, goes in another decorator. You want to do some caching, goes in its own decorator. Now, all that logic only lives in one place. It's really simple to read. It's tiny. It's only doing one thing. And it's not cluttering up your application code, and it's not cluttering up your individual adapter code.
Yeah. I love using that pattern where I want to insert some cache. If I'm just making calls, and I'm making a lot of calls, but by golly, this data or whatever the source is, it doesn't change every millisecond or even every second or sometimes every minute. And I just noticed, man, this is really, really chatty. I don't want the client, if I don't want the client or the caller to have to manage the chattiness, I want to manage it, then I love that just for inherit from the same interface, use some type of chat implementation. And then when I bypass the chat, go to the regular implementation
Cache.
And instantaneously I can cut the number of calls by a factor of whatever I want, depending on how I cache it.
Yep. Yeah,
and it's so simple.
Yeah, and there's a type of architecture that I've grown really fond of recently that some folks call pipeline architecture, where it's basically middleware, like we have an ASP.NET Core, if you have ASP.NET Core developers in your audience. And it's the chain of responsibility pattern is the actual design pattern that's being used, but we mostly just call it middleware these days because that's what it's called inside of web applications and how request handlers work. But the idea is essentially a bunch of decorators that fire off one after the other in sequence, and each one is wrapping the thing inside. The difference is from a traditional decorator is that every single one of the handlers in the line has a common interface. Right. So instead of me having to create a special logging decorator for my file system abstraction because it has a save method, well, now I have to make my own logging file system decorator, and it has to have a save method, and it has to take in exactly those arguments, and then it has to call the underlying real file system whatever thing, right? And then I'll add my logging around it. Well, I probably have a lot of different services that I want to log, and now I've got to go write decorators for all of them. And every one of those services has a different interface with a different set of methods. And every one of those methods needs its own separate implementation to do logging. And oh, wait, I want to do error handling too. That's another whole bunch. And I want to do caching too. So that's another whole bunch. Like it ends up being a lot. And that is a valid criticism of using decorators too much. Right. And so the way that the chain of responsibility principle gets around that is it says, you know what, we could use inheritance to solve this problem if we could just agree on a consistent interface, not the C# interface, but the method signature interface of the thing we're calling. And so if you use tools like Mediator or Mass Transit or other tools that use message handling, you'll see that they almost always have some type of an interface for handling a message, right? It's an iNotification handler, for example. And the only thing on that interface is a handle method that takes in some T request, generic argument, returns back some T response, result, and that's it, right? And so that allows you to create these pipeline behaviors or middleware that you can write them once and they'll work for anything that uses that handler interface. And so then if we go back to that use cases project I mentioned, and you have those commands and queries, well, every one of those commands and queries becomes a message that has a corresponding handler. And all those handlers have the exact same interface, which means that they can leverage a very small number of common middleware behaviors that will do those cross-cutting concerns.
Yeah. As you were talking about that, I realized that I found myself favoring very early in an application's design the introduction of kind of like an overarching in-memory bus pattern where for a certain section, I may want that chain of responsibility. In another section, I may want just the single request, single handler, and use mediator library. Or I may want to even, have it remote over to Azure Service Bus for durable or guaranteed delivery. But I find myself just putting in a very simple bus pattern, which then kind of is an umbrella, sits on top of the other ones, just so that I have that flexibility to have the different, whether it's single command, single handler, or durable delivery out of process, or fire and forget events where there may be a handler to listen for the event, or there may be nothing and the event just kind of falls out into the ether and doesn't get handled, but it can handle all the styles. And I found myself putting that in so many times that's becoming one of my habits. Like, you know what? I kind of am going to need it. So I'm just going to put that in now and then bolt everything on. Do you end up favoring that with chain of responsibility, or do you?
Yeah. Like I said, my decisions are often based on my own experience and what the client needs. And most of my clients are not building CRUD apps, right? I'm not the right guy for them to call if they just need to build a CRUD app. I'm way too expensive. So, they're coming to me because they have some complex business logic and they're struggling to try and build a system around it that they can maintain. And in those types of scenarios, I'm going to favor stuff like domain-driven design that makes it easy to tackle complexity, unit tests and CI/CD and all those best practices that we've all heard. And clean architecture for me works really well with that because I will create use cases like I was talking about that correspond to all the commands and queries, and there will be a handler for every one of those. And then there will be cross-cutting concerns managed by pipeline behaviors. And typically I'm just using Mediator. I've experimented with some other libraries, so I'm not married to just that one. But in the times when I've decided to switch one for another, different messaging libraries, it's pretty trivial, right? Like essentially you're going to have some DTO message and you're going to have something that calls send or send async or whatever the method might be called. And that's going to map to a handler, and that's it. That's all the code there is. So if you switch from one to another, it's a lot of refactoring, jumping through all the places where you called send, and modifying that if you need to, and then you're done. So it's fairly flexible. And I personally haven't generally created my own custom message bus on top of that. I will go so far as to maybe give some specific type names for things. So like Mediator doesn't have any concrete concept of a query versus a command, right? It has notifications and something. And so I'll usually create abstractions specifically for queries, commands, and events, because those are the three messages I'm going to use.
Right.
I'll create interfaces for them. So it's really intention revealing to anyone on the project. If they look at that, they know what this DTO is for.
Right. Well, as we close up, let's close up with a bit of conjecture. A little bit of forecasting, looking into the future, guided by, a good number of years' experience. Before the show, we were talking a little bit about AI-driven development and how it might modify or change how we make architectural decisions and what it's gonna do. I've been experimenting with Copilot and JetBrains AI assistant, and of course keeping tabs on all of the other ones and what the capabilities are. And so from your perspective, when we see, okay, yeah, for certain type of code, it can generate a whole bunch of stuff, and maybe for a certain type of code, I don't need to hand code that type anymore. But then maybe there's different types of code where, I just don't see it yet. I think we need to, carefully craft that ourselves. In your opinion, what do you see happening, or what's already ready right now, and what do you see as very, very likely over the next, I don't know, some number of years?
I think AI is obviously huge, and some of the things I'm using it for are finding answers to quick questions when I'm troubleshooting. I haven't searched Stack Overflow in a while now, but I'll ask ChatGPT, like, why am I getting this error message? And it'll give me 10 different things to try within a couple seconds, right? And none of them will come with snide remarks about why I should know this already, and why are you even asking this question? And it's probably a duplicate, which I think are nice features over certain other places. But aside from doing that, as far as code generation, I think it's really good at that too, to an extent. It depends on how you work with it. I've seen a lot of folks in the last 6 months or so describe that it's interesting that the industry has learned that you can use LLMs to help generate code, as long as you go in very small steps and you're very clear about what you want, and you iterate and you get lots of feedback and tell it all the things it needs to know. And it's like, those were all best practices for how you would tell a junior developer to do that stuff too.
Right,
we just didn't do it. We would just give the developer a 3-sentence story card and say, go code this for a week, and then complain a week later that they didn't build the right thing. Like, no, if you actually talk to them, in short little intervals and tell them very clearly what you want, that junior coder could have done the same things that the LLM could. So I think that's interesting. The other thing that I see a lot, though, is that it generates a lot of not dense, but it generates a lot of code that you don't always see an easy way for it to refactor into something smaller, right? Because of the limitations on the numbers of tokens, the expense of expanding that number of tokens, right? There's only so much code you can give it. And we're not at a state yet where you can take an enterprise software application, put the entire thing into the model, and then say, hey, I want you to refactor this. Why don't we switch from this architecture to that one? Or why don't you apply the chain of responsibility principle to this area of the code base? I think we'll get there, but we're not there yet today. And so today, if you're trying to do that, you're copy pasting a few classes that you've got and putting them into it, and then saying, hey, I want to do X, Y, Z. How can I start? And then it's going to kind of help you, but it's not going to follow your standards. It's not going to use your formatting style. It's going to invent some methods that don't exist. And, we can't really stop that because it's just a statistical model. It's not using a compiler or anything internally. And so there's going to be limitations. And so I think it's going to generate a lot of code. I think it's going to be best at generating net new code that is not part of a large existing system. I think that folks are going to get really excited about how quickly they can build things for the first 3 months. And then they're going to hit a plateau and a cliff where it stops being fast and it starts getting hard. And the code that's there won't necessarily be something that the person that built it, he says in air quotes, understands at all, because the AI really built it. The AI certainly doesn't understand it, because that's not how AIs work. Maybe if you can get all of it back into the AI, it could understand it enough to generate another, sequence of words. But it doesn't understand it like a human software developer might. And I think that means that just like we saw 20 years ago, when every enterprise in the United States suddenly got on the same bandwagon and said, hey, we could ship all our software developers over to Asia for $15 an hour, right? And fired and laid off all their local developers. About 10 years after that, most of them had hired back a lot of local developers, because they found that, yes, things went really cheaply and really quickly for about 6 months to 2 years, and then kind of fell off a cliff and got really slow because there was a lot of technical debt and a lot of problems and, other issues that they ran into. So I think we're going to see the same thing. I think there's going to be a whole lot of AI code that's going to need a whole lot of help re-architecting and refactoring in the next, let's say 3 to 5 years.
Yeah. One example that I did recently had that was I was pleasantly surprised that it went well was a .NET 4 application. So pre .NET Core and the switch over, which Microsoft they at the build conference in the Copilot sessions there was one question. So will it upgrade my .NET Framework apps to .NET 8? And they said no. But we were upgrading this older .NET application, but it had good tests, had good test coverage. And I personally, I looked at this old in Hibernate mapping, which, the people who have good experience with in Hibernate mappings are you got to be older people, right? So
yeah. But the AI knows it.
Right. So I kind of knew it and had gone deep in Hibernate way back when. And it had a lot of tables and whatnot. And so I was able to get Copilot to just kind of isolate these in Hibernate mappings. I literally copied and pasted the SQL Server schema into the context window so that it had the tables. And then, and I did a little trial and error, compile errors and whatnot. After asking it to modify it to the equivalent Entity Framework core, I gave it the instruction of recompile until there's no compile errors remaining and run the tests until all of the tests are passing. And it just sat there and churned and churned and churned and churned. And it almost did the entire data layer, except there was one mapping. It was mapping a list with a composite key with a sequence column where the positional nature in the list was saved to the database. It couldn't figure that one out, so I did that by hand. But it got everything else. And so
Nice.
I was really excited about that because it can't do the whole application, but piece by piece, I can see it right now helping big time upgrade just .NET Framework applications.
I've heard horror stories, though, about it also deciding when given such instructions that it could just change the tests, or it could just comment out or delete the tests. And yeah, you know what? Now it compiles and all the tests pass. Here you go.
Well, of course you got to watch that. In this case, it didn't. But I mean, I'm on a feature branch, and if it's total trash, okay, start over with a new feature branch. Or no,
Right.
but yeah, you obviously don't want to do that.
All right. Well, I'm glad it didn't do that for you. But yeah, I've heard of that, and some folks have got it integrated with GitHub, where it's actually doing Git pushes as it's making changes. Right. So manipulating the source. So the one story I remember hearing, the person in question had been doing this for a while, but they had almost lost their last version of the code because they had a version of it that was still local in another folder, but they had been letting the AI doing stuff with the remote repo, and it had committed stuff and pruned stuff and modified things, and they didn't notice for a while, and so things had been cleaned up. And then they went back and saw like, oh crap, all these tests I used to have aren't there anymore. And so they managed to recover them. But now, of course, they're way out of date because they were not part of the main flow, but they at least had them. So yeah, I think like you gotta do some code reviews on these things too. For sure.
Like all the same DevOps practices that keep you safe and keep you stable and working in small increments still apply.
Yes.
So what close up final thought. Is there a certain type of code or application type that you look forward to not hand coding anymore?
I've never been a fan of CSS, and so I love using AI for building CSS and UIs stuff. And I'm sure my CSS is full of tech debt and doesn't use best practices when I do that. But I love that I'm able to make stuff that looks reasonably decent, and I don't have to spend hours trying to trial and error my way through it. So I do enjoy that.
Nice.
I will say, on a more back end development side of things, I think that the days when we're coding every individual API endpoint are not going to last forever. And at some point, we're going to have something like GraphQL that is able to just take in arbitrary commands from Blazor or React or Angular or whatever it might be to a single endpoint or maybe a couple of endpoints, and then translate those all on the server without having to have hand-coded controllers and API endpoints for every single type of message that someone might send over HTTP.
Yes. Yeah, that is tedious. Well, awesome. Hey, this is a great conversation. Steve, thanks for coming back on the show. And enjoyed catching up and talking some architecture with you.
Yeah, same here. Glad to be back.
Awesome. My pleasure. My pleasure. And until next time, dear listener, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.